Rationalize the denominator. So what that means is to simplify, so there is no radical in the denominator or on the bottom of the fraction. So if I gave you this problem and I said simplify the square root of 4 over 5. So again, first thing you always want to look for is, can the stuff that you do have simplify? If it can't, then you need, or can the number simplify underneath the radical? So 4 divided by 5 doesn't simplify. But remember, we can rewrite it as the square root of 4 over the square root of 5. Just like when we split it out when they're multiplying, if they're dividing, you can split them out. Now it's the square root of 4. Well, what number times itself is 4? Or if you did the factor tree of 4, you would get 2 and 2. Remember, if there's no number written here, sorry, that's a 2 if you can't see that. If there's no number written here, there's an implied 2. So I can rewrite 4 as 2 squared, and the square root and the squared cancel. And then the square root of 5 is just, if you did the factor tree of 5, it would just be 5 and 1. Well, that doesn't simplify, so it would just stay the square root of 5. So it'd be 2 over the square root of 5. Now, that should be stuff that you've already done and you're familiar with. What rationalizing the denominator does is makes it so that this radical will go away. Well, if I want this radical to go away, since there's an implied 2 there, I need to make it so that it is 5 squared, so that the square root and the squared cancel out. Well, in order to do that, I need to multiply by 5, but since the 5 is under the radical, I'm going to have to multiply the 5 as a square root. So I'm multiplying, and we need to show that it is on the bottom. So I need to multiply by the square root of 5. It has to be under the square root, so that again, I can write it as the square root of 5 times 5, or the square root of 5 squared. But all of that is in the denominator. Also, something to think about is you cannot just multiply by any random number that you feel like. You always have to multiply by 1. So in order to make this multiplied by 1, you need to multiply by the same thing on the top. So I'm going to write this note. Always, oh good, my pen is not working. Multiply by 1. So same thing on bottom and top. So example would be square root of 5 over square root of 5. So then now if you look, it would be 2 times the square root of 5. And then again 2 times the square root of 5. Since 2 is not under a radical, you cannot put it under the radical. Then the square root and the squared cancel. So your final answer would be 2 square root of 5 over 5. And notice the 5 is no longer in the radical because we changed it to be 5 squared, and then the square root and the squared cancel. Okay, next example. Let's do 2 over the cube root of 9. So there is no simplifying I can do up here. 9, if you think about it, is 3 times 3. Well, that is not a perfect cube, so you are going to just have to, so you're going to have to rationalize the denominator. Now, if you think about this, as a little side note, you don't want to multiply 9 times 9, because if you multiplied 9 times 9 here, just like we did times the square root of 5 up here, 9 times 9 would be 3, 3, 3, and 3. Notice that's 1, 2, 3, 4 of them. And if we did that, we would still end up having a cube root. So we only need to multiply here. So let me rewrite this over here. Sorry, I ran out of room. So I only need to multiply it by a 3. It's already 9. So I need to do 9 times 3. And then notice I would have 3 3's. So I need to multiply by the cube root of 3. This is that same rule right there. So I need to multiply by the same thing on top and on bottom. That's a cube root of 3. Because 9 times 3, well, there's already 2 3's here, or 3 squared here, and then we can multiply by another 3 and it would be 3 cubed. So then this would become the cube root of 9 times 3, or 3 cubed, all under 2 cube root of 3. Cube root and cube cancel, so it'd be 2 cube root of 3 divided by 3. So again, you didn't want to just multiply by this identical thing like we did up here. You would want to multiply by whatever you need to complete the cube. So remember, a cube and a cube root cancel. All right, another example now using variables. So if we have 8x to the 5th y times x to the negative 1/2. So this is a new example. Oops, and I just marked through that stuff, sorry. Now, I put this problem on here because I wanted to show you, remember, when you have an exponent like this, it only applies to what's in parentheses or what's directly in front of it. So the only thing inside of this parentheses is x, so that's the only thing that applies to this. So if you have a negative exponent, I personally always deal with the negative exponent first, but again, you can always do it whichever way. So I'm going to get rid of the negative exponent. Remember, a negative exponent, this is what we learned on like the first day of this unit, is a negative exponent always moves it to the bottom, or the denominator. So that would cancel. So then I would have 8x to the 5th y divided by x to the 1/2. And then if you remember, it would be 8x to the 5th y, that's still the same. And I'm going to rewrite the 1/2 as a radical. So the denominator becomes the index, so it would be 2 square root of x. Now, in order to make an x, or get rid of the square root, remember I need a squared here, so I need a squared. Well, in order to get a squared for an x, I need to multiply by another x. Since this is underneath the radical, I need to multiply it under the radical again. And then whatever I'm multiplying on the bottom or in the denominator, I need to multiply in the numerator. Okay, now I can rewrite the top as 8x to the 5th y square root of x divided by, I can rewrite this as x squared, and then the squared and the square root cancel. So then in the denominator, all I have is x. And that would be your answer.